Hello and welcome everyone. This is Mohammad Izamam from SAIMEDHA ECET Coaching Center Koti, Hyderabad. SAIMEDHA Koti, Hyderabad is providing a golden opportunity to all the ECET 2024 and as well as ECET 2025 students. ఎవరైతే ఫైనల్ ఇయర్ లో ఉన్నారో, ఎవరైతే థర్డ్ సెమిస్టర్ లో ఇప్పుడు చదువుతున్నారో, SAIMEDHA Koti, Hyderabad is providing the online coaching and as well as offline coaching for it. ర్యాంక్స్ గురించి చెప్పాలంటే SAIMEDHA Koti, Hyderabad లో every single year we have proven that maximum ranks in all the branches ECE, EEE, mechanical, civil and computer science లో టాప్ 5 branches లో స్టేట్ ఫస్ట్ ర్యాంక్ తో పాటు maximum ranks in top 10 and top 50 లో కూడా maximum ranks are there. In this video lecture series in the YouTube, we are going to be updating every single day for all the branches subject wise and as well as topic wise. Previous ECET examination questions will be explained by expert faculties. My dear students, gurtu pettukondi, only previous year competitive examination questions korake separate course untadi, pay cheyalsi untadi baita market lo, kani SAIMEDHA Koti, Hyderabad lo free of cost we are providing that series guys in this very YouTube channel. So those who have not subscribed the channel, subscribe now and press the bell icon to be notified for the further more updates. Every day subject wise, topic wise, previous ECET examination questions with which you can understand the level of teaching, the expertise which is there in the SAIMEDHA Koti, Hyderabad. So my dear students, what are you waiting for? Start watching all the video series in this YouTube channel. At the end of the video, I'll be coming back to give you a surprise for all the ECET 2024 and ECET 2025 aspirants. So share this video as much as possible for all the final year students and third semester students. Now let's start the video. The next question is, in isentropic process of a temperature versus entropy diagram, it's going to look like TS diagram is talking about. This is temperature versus entropy diagram. Okay, that is temperature remaining constant temperature. This is constant entropy. Okay, constant entropy, constant temperature. Constant temperature isothermal horizontal line. This one is a constant entropy. It is going to become a vertical line. Whereas constant volume, constant pressure. This is constant volume. This one is constant pressure. Both are curves. We require this constant entropy, isentropic process. Isentropic process. This is 1. This one is 2. If you are going to plot this, S1 is equals to S2. That is a vertical line. Okay. It is a vertical line. Remember this. One more important point is there regarding constant volume and constant pressure. This is volume equal to constant. This is pressure is equals to constant. Remember always, constant volume slope is, let's say this is alpha, this is beta. Constant volume slope is always greater than constant pressure. Constant volume slope is always greater than constant pressure slope. Constant volume slope is, let's say this is volume is equals to constant, this is pressure is equals to constant slopes. So you're gonna read it like this: slope of volume constant process is greater than slope of constant pressure process. But both are curves in the temperature versus entropy diagram. Temperature versus entropy diagram. Asked the question now is, over the temperature versus entropy diagram, isentropic line is horizontal na vertical na? It is a vertical line. Okay, go for the next question. Throttling process. This is the third time now. This is the third time this question is reappearing. Okay, that means same concept. Third stream throttling. Throttling means what? Enthalpy is constant. Throttling means what? Enthalpy is constant. That's what he is asking there. Enthalpy remains constant. So which one is the correct answer? Option 3. Okay, third time throttling. First time throttling is appeared. Second time throttling is appeared in Clausius-Clapeyron equation form. No, is asking pressure. Pressure decreases, enthalpy constant. Enthalpy constant. Again, steam enthalpy now constant. Okay, third time it is. Go for the next question. The relation between vapor pressure to that of the enthalpy of vaporization. Again, it is related to throttling. I told you a formula: Clausius-Clapeyron equation. Clausius-Clapeyron equation. What is it states? It states that P by T is equals to S by V. Dou P by dou T equal to dou S by dou V. Where change in entropy formula is heat transfer with temperature, latent heat divided by saturation temperature, that is HFG divided by TG, that is Hg minus Hf divided by T saturation, okay, Tg. So here we can write S by V, that is Hg minus Hf or HFG also you can write, it's up to you, divided by T saturation into given change in volume. So enthalpy of vaporization, that is called as latent heat. Enthalpy of vaporization, that is called as latent heat. This equation is given by which equation? Clausius-Clapeyron equation. What do we call it as? Clausius-Clapeyron equation. Usually it can also be written as Maxwell equation, but when we are going to substitute it in the form of enthalpies, in the form of latent heat, it is regarded as Clausius-Clapeyron equation. Okay, go for the next equation. Next question. During the cycle of thermodynamic processes, 2 times 16 is not there, only one time. 120 minus 16, 48, 12. Okay, net work done is equals to, we know that net heat transfer is equal to net work transfer. So net work transfer is equals to what is the value given? 120 minus 16 minus 48 plus 12. This value will be around 68. That's all the sum you need to take. So what is the correct answer going to become for this question? 68 kilonewton per meter. Okay, add all the heats which are given, positive and negative. Whatever the total summation of heat you are going to get, summation of heat is equal to summation of work. That's why 68. Throttling process. This is the fourth time this question is coming now. Fourth time from the throttling we are seeing the question. Okay, in the throttling process, which of the following property is not affected? Expansion, I told you, enthalpy remaining constant. Throttling means enthalpy remaining what? Constant. This is the fourth time this question is appearing, enthalpy constant. So now you can see this throttling, how much it is important, right? Go for the next. 100 kilojoules of heat is supplied to 1 kg of air at constant pressure. The temperature increases from 25 to 120, find the change in entropy. Change in entropy formula is what? C log T2 divided by T1. What is the C value? 1.005, because it is air. Because it is air. Cp value 1.005, Cp value 0.717, gamma value 1.4, 1.0, Cv value 0.717, R value 0.287, Ru value 8.314. Okay, I have to memorize these values. Kilojoule per kg Kelvin, kilojoule per kg Kelvin, kilojoule per kg Kelvin, joule per mole Kelvin. Gamma value is equals to 1.4. Okay, these all values are there for air. This is universal gas constant which is never going to change. Okay, here Cp log T2 by T1. T2 value is going to become how much? You see here 120, 120 plus 273, this is 3, this one is 9, this one is 3, this is 393. 393 divided by T1. T1 value is, what is it gonna look like? This is 8, this is 9, this is 2, 298. 298. If you are gonna solve this value, guys, you are going to get an answer of around 1.3. Log 1.3, log 1.4, log 1.5, approximately values you need to know. That is 1.3, you are going to get approximately answer as 0.3, that is 0.28 something, 25 something you are going to get. Just 0.26 I am writing, okay, into 1.005, around 0.28, because greater than 1 value, greater than 26 value you are going to get. So this is 0.27 or 8 something. So nearmost value is going to become 0.289. This values you need to know. That is log 1.3 around 0.3, that is 0.26 something. Log 1.4 around 0.33. Okay, log 1.5 around some 0.4745, like that. Okay, so few values you need to know. Or directly if you want to do the problem, ds is equals to d dash q divided by t, where t, this is t higher temperature, because heat is getting supplied. We are having the value of around 100 kilojoules divided by heat temperature. It's around 393, that is 1/3, that is 0.3 ki దగ్గరున్న value రావాలి మనకు. Okay, 1/4 actually, 1/4 is 0.25, but this denominator value is decreasing, so overall value what happens? Increases. So 0.25 కంటే greater value రావాలి. So what is it now? 0.289. So correct answer is 0.289. So option number 4. Vice versa, you can do this problem like this also, or in this manner also. Okay, చూసుకోండి ఒకసారి. Pause the video, note it down. Let's go for the next question. A process in which no heat is supplied or rejected and entropy is a constant. Then this process is called as isentropic process. Standard question. No heat supplied, heat transfer is equals to 0. What is the formula for change in entropy? D dash Q divided by T plus entropy generation. He is saying about entropy is constant. That means ds is equals to 0. That means this is equals to 0, this is also equal to 0, this is called as reversible, this is called as adiabatic. So what is the correct answer going to become? Reversible adiabatic. Entropy constant, similar isentropic process. So option 1 is going to become the correct answer. Go for the next question. Reversible polytropic process can be described by the equation polytropic PV to the power of n is equals to constant. PV to the power of n equal to constant. So what do we have here? PV power n, volume power n, not total whole n gaadu, PV power n, volume power n you need to have. Okay. Go for the next question. Isothermal process, the internal energy is, okay, we know the formula d dash q is equals to du plus d dash w. We know that in the isothermal process, du formula m into Cv into dt. Isothermal temperature is what? Constant. Differentiation of temperature is equals to 0. That means this dt equal to 0. du is equals to 0. u1 minus u2 is equals to 0. u1 is equals to u2. u is constant. This question is again repeated question. This question is also repeated question. So internal energy is constant. I told you internal energy is a function of temperature. Temperature increases, internal energy increases. Temperature decreases, internal energy decreases. That means temperature is remaining what? Constant. Internal energy is also remaining constant. This law is called as Joule's law. What is it called as? Joule's law. This is also appeared question in 2023. Okay. Many times, 3 times appeared question. This is also. But not from this chapter. It is there from the fundamentals concept only, where we discuss about laws of thermodynamics, perfect gas laws. Chalo, go for the next question. The heat supply during the constant volume process is 30 kilojoule, the internal energy is. Volume is remaining constant, again box formula. Volume is constant, then heat transfer and internal energy both are what? Same. Heat transfer given as how much? 30 kilojoule. Asked question is change in internal energy is equals to what? What is the answer? 30 kilojoule only. Because in constant volume process, heat transfer and internal energy both are same. Okay. This already we have seen in the box. First question, question number 1, refer question number 1. Question number 1 only, this box we have discussed. Go for the next question. The process in which no heat is supplied or rejected and entropy is constant. Already repeated question, 2 times. Repeated question. ds is equals to d dash q divided by t plus entropy generation. Entropy generation 0, heat transfer equals to 0, ds is equals to 0. Entropy is what? Constant. Entropy constant, another name is what? Isentropic process. Isentropic process. Okay. Entropy is constant. Isentropic process. Go for the next question. Now, work done during this cycle is, if diagram is not available, observe this is looking like this. This is the heat supply value 2800, this is the heat rejection value, it's around 700, this is heat rejection, this one is heat supply. Asked question is work done. Work done is heat supply minus heat rejection. That is 2800 minus 700, that is equals to 2100 kilojoules. Very simple question. So what is the correct answer going to become here? Option number 2. Have to memorize work done formula. Work done is heat supplied minus heat rejection. Go through it. Try to memorize the formula. Okay. Chalo. Pause the video, note it down. Go for the next question. Heat supplied during the constant volume process is 45. Internal energy is equals to. Again box. Question number 1. Constant volume. Constant volume heat transfer is equals to internal energy change. What is the heat transfer given in the question there? 45 kilojoule. What is the asked question? Internal energy is equals to what? What is the answer going to become again? 45 kilojoules. Internal energy. Its internal energy would be 45 kilojoules only. Okay. Go for the next question. Reversible adiabatic process. This is the 4th time I guess. 4th time this question is getting appeared. Reversible adiabatic. ds is equals to d dash q divided by t plus entropy generation. Entropy generation is 0 because it is which one? Reversible. Heat transfer equal to 0 because it is what? Adiabatic. Reversible adiabatic, ds is equals to what? 0 plus 0, that is 0, ds is equals to 0, it is isentropic process. What is it? Isentropic process. Change in entropy value he is asking. Change in entropy, what is the value here? What is the change in entropy value? 0. What is the change in entropy value for reversible adiabatic process? It is 0. Okay. Go for the next question. In throttling process, this is the 5th time this question is getting appeared. 5th time, that is throttling process. Throttling process. Enthalpy is what? Constant. Enthalpy is a constant. Throttling process enthalpy is constant. Which one of the following property is not affected? That means constant property he is asking. What is the correct answer? Enthalpy. Throttling, isenthalpic, enthalpy constant, Clausius-Clapeyron equation, steam enthalpy remains constant, enthalpy decreases, enthalpy constant, pressure decreases. Okay. These all are there in the previous ECET questions only. Just you mark it out all the throttling questions, you will see how many times this question is getting repeated. Okay. Go for the next question. A cycle consisting of one, this is from the air standard cycles, but question appeared, that's why let's see. You are having constant pressure process, constant volume process, and 2 isentropic process. This is heat supply, this one is heat rejection, and this cycle is called as diesel cycle. What is it called as? Diesel cycle. Actually, it is a question from air standard cycles chapter. When that chapter comes, we will see this question there also. Okay. Go for the next. A mass is given m perfect gas P1 V1 log V2 by V1. What is the formula for work done in isothermal process? P1 V1 log V2 divided by V1. V2 divided by V1. P1 V1 can be written as mRT1 log V2 divided by V1, or it can also be written as nRUT1 log P1 divided by P2. Okay. Observe. What do we have given here? P1 V1 log V2 divided by V1. This is the correct answer. This question could also be correct when it is given as compression work. Okay. This formula can also be written when mass is equals to 1 kg, mass is equals to 1 kg. But here mass is given, right? Mass is given. So that's why you need to multiply here mRT. So correct answer is what? Option number 2. Chuskondi okasari. Pause the video, note it down. Let's go for the next question. Work done in a free expansion process is, okay, there are 2 processes that we need to memorize. Free expansion and throttling expansion. In both this process, work done is equals to 0. Work done is equals to 0. Heat transfer is equals to 0. Heat transfer to 0. Okay. So what we can write the correct answer for this question? Throttling expansion, free expansion. Free expansion work done is equals to, what is the value? 0. Okay. Go for the next question. Change in entropy for irreversible process is, ds is equals to d dash q divided by t plus entropy generation. This entropy generation is always which value? Positive value. Positive value for which process? Irreversible process. So irreversible process ki entropy eppudaina sare em untadi? Positive value e untadi. This is the answer. Change in entropy for an irreversible process is always dash. Answer is what? Positive. Next question. Thermodynamic relation in between volume temperature. We know the formula. V2 divided by V1 is equals to P1 divided by P2 whole to the power of 1 by n, that is equals to T2 divided by T1 whole to the power of 1 by n minus 1. Now he is asking the relation in between volume and temperature. This is volume and this is temperature. Then what is the relation? Observe. V2 divided by V2 by V1. This is, wait a minute. This is 2 1, so here need to write T1 by T2. Now it is correct. Okay. V2 by V1 is equals to T1 by T2 whole to the power of 1 by n minus 1. Okay. Sending this 1 by n minus 1 to the left hand side, what is it gonna become? V2 by V1 whole to the power of n minus 1 is equals to T1 by T2. In the option you don't have T1 by T2, you have here T2 by T1. So let's inverse the both. T1 by T2 will be written as T2 by T1. If temperature is reversed, then this also should be reciprocal, right? So V1 divided by V2. This is V1 divided by V2 whole to the power of n minus 1. So this is your formula. T2 by T1 is equals to V1 by V2 whole to the power of n minus 1. 2 1 1 2 n minus 1. Now it is correct. For that you need to memorize first of all relation in between volume, pressure and temperature. Volume, pressure, temperature. If you remember these three, any relation you can write: volume, pressure, temperature, pressure, volume, pressure, temperature. Okay. Okay, let's go for the next question now. The next question given is during the compression process. Compression means what? Volume is going to be decreasing, pressure is going to be increasing, or pressure increases is what we can call it as a compression process. Let's say compressor. Compressor is a which system? It is an open system. For a open system, area of PV diagram, area under PV diagram plotted over y-axis, plotted over y-axis. Observe here. So what are we going to do here is, so this is the pressure increase up to here. So you can watch this curve, this curve, this curve and this one. So we are having four processes. Let's say this first one is, this is first, let's say this is second, or I will give it the number based on the options. Okay. First one is isentropic. This is the isentropic process. Isentropic process, that is PV to the power of gamma equals to constant. Gamma, this is PV to the power of 1, that is this is isothermal process. Isothermal is option 2. Okay. In between isothermal and isentropic, we are going to be having polytropic. This is 3. And the last one, this is fourth one, this is isochoric process. Now tell me, if I am going to start plotting the areas, okay, let me take the area 1 first. This is the area 1, okay, isothermal, which is least area, okay. If you see the second area now, this is the second area, okay, this is the second area, that is for 3, polytropic process. If you see the third area, this is the third area, that is somewhat again more isentropic, but the maximum area which we are able to see is from where to where? From isochoric process. This is the maximum area you can see. So maximum area is the maximum work. So if you want to write the work of compression formula, what we can write here? Work of isothermal is lesser than work of polytropic, is lesser than work of isentropic, is lesser than work of isochoric. Okay, so maximum work done is there in which process? Work done is maximum in which process? Isochoric process. Minimum work is there in which process? Isothermal process. Okay, remember this, very much important. Let's go for the next question. A gas expands 0.025. We know the work done formula is pressure into change in volume. Pressure is given as 2 into 10 to the power of 6. Volume is given as 0.075. 0.075 minus 0.025. This is 0.05 into 2 into 10 to the power of kilo is what we require. So I am writing here 10 cube and kilojoules. So this is going to become 0.05 into 2, 0.1 into 1000. 0.1 into 1000 is going to become 100 kilojoules. Okay, this is work done. What is the heat supply given in the question? 150 kilojoules. What is the asked question? Internal energy is equals to what? We know the formula. Heat transfer is equals to internal energy plus work transfer. Heat transfer is 150, work transfer is 100. What is internal energy is equals to? Internal energy is equals to 150 minus 100. What is the answer? 50 kilojoules. Same question already previously appeared. Okay, I told you 80 kilojoule, 30 kilojoule, 80 minus 30 is 50. Okay, that problem twice appeared. Little bit change in the values, but again the answer is again 50 kilojoules. Okay, similar question. Pressure, change in volume. Heat is given, internal energy asked there. Okay, let's go for the next question. During isentropic process, you can see this is 6th time or 7th time this question you are seeing there regarding the isentropic process. Isentropic process, ds is equals to 0. Entropy is constant. Entropy is constant. Isochoric volume constant, isobaric pressure constant, isothermal temperature constant, isentropic, iso same, okay, iso entropy same entropy, entropy constant. So what is the correct answer here? Entropy is constant. Where is the entropy constant? Okay, so heat transfer 0 we can say, because we know the formula, change in entropy is equals to d dash q divided by t, where this one is going to become 0, then only the ds value is going to become 0 and entropy going to become constant. So heat transfer is 0, going to be the correct answer, because internal energy remains constant, temperature constant, energy constant, these options are same. Entropy increases. Isentropy process, entropy does not increases, entropy remains constant. So the best option among these 4 is option number 4 only. Heat transfer equals to 0. Okay, go for the next question. I told you PV to the power of n is equals to constant, n values, PV to the power of n is equals to constant, n value 0, n value infinity, n value 1, n value gamma, 1 is lesser than, n is lesser than gamma. Where n value is equals to 0, it is called as constant pressure process, n value equals to infinity, it is called as constant volume process, n value equals to 1, this is called as PV is equals to constant, that is temperature is equals to constant, isothermal process. Already this box we have written, n equal to 1, n is equals to 1, PV to the power of n is equals to constant, n plus 1, PV equal to constant, temperature is equals to constant. What is it? Constant temperature. Okay, gamma vaste, PV to the power of gamma is equals to constant, it is called as isentropic. And the last one is polytropic. Tell me, n is 0, anything for 0, this is 1, pressure is constant, volume is constant. Okay, go through that box, try to memorize it. Okay, go for the next question. Next question given is n equal to 0, polytropic process, n equal to 0. N is equals to 0 is for which process? Constant pressure process. He is saying in the question, n is equals to 0, then the process is termed as constant pressure. What is the meaning of constant pressure? Isobaric. So this is ECET 2023. Very simple paper, guys. If you people can solve only the previous ECET examination question also, you could have performed well in the examination. So definitely those who are ECET 2024 aspirants, 25, 26, further future, many aspirants, what we need to do? Practice previous ECET questions topic wise which are available in the SAIMEDHA KOTI app. Okay, chalo, pause the video and note it down. So my dear students, for ECET 2024 and ECET 2025, SAIMEDHA KOTI Hyderabad is providing maximum concessions in this very week. Offline students gavachu, online students gavachu, online plus offline students gavachu, morning batches, evening batches, day batches, full day batches, online courses with materials gurinchi SAIMEDHA KOTI Hyderabad in this very week, guys, in this very week only we are providing the maximum concessions. Aa concessions evaithe unnayo, concessions ee vidhanga untadi, batches ee vidhanga untadi, with materials, without material, online coaching, total మీకు ఏ డౌట్ ఉన్నా సరే ఆ కన్సెషన్స్ మాక్సిమం ఏమున్నాయి అంటే మనకు మొబైల్ నంబర్స్ ఇక్కడ స్క్రోలింగ్ లో ఆల్రెడీ ఇవ్వడం జరిగింది. సో స్క్రోలింగ్ అవుతున్న మొబైల్ నంబర్స్ కి కాంటాక్ట్ చేయండి అండ్ జాయిన్ ఇన్ ద SAIMEDHA KOTI Hyderabad as soon as possible. Don't miss this opportunity of getting the maximum concessions, guys. Thank you very much. In this video series, every single day we are going to be updating subject wise, topic wise, previous ECET examination questions. I wish you all the best. This is Mohammad Inzamam signing off.